Hello, good morning to all of you. We are studying the unit number 3rd in that 3.1, that is IUPAC nomenclature of the spiro compound and bicyclic compound, and third one is the biphenyl compounds. So in this, we are on the second, that is we have studied the spiro compounds and its nomenclature. Now we are on the fused and bridge ring systems. In the fused and bridge ring systems, we have studied the rules and regulations. So in this way, now we are on the example parts. Here the examples. Numbering should be start from the bridge carbon atoms. Numbering first give to the rings which is larger in size. It is opposite to the spiro carbon atoms. So now we are on the example number 4, having the three carbons bridge ring systems. So this is all about the bicyclo compounds. Numbering start from the bridge carbon atoms. Bridge carbon given the number 1, then both the rings are of same size, so we prefer to number which rings that having the substituent attached. In that also, numbering start from those bridge carbon atoms which is having the near to that substituents. So 2 hydroxy means 1, 2 position, 3, 4, 5, 6, 7, 8. Total number of carbon 8 means octane. And at the 2 position there is a hydroxyl group, that is 2 hydroxy bicyclo 3.3.0, that is octane. So 3.3.0 octane is the compounds. 3.3.0 octane is the compounds. So this is the nomenclatures of the compounds, that is 2 hydroxy bicyclo 3.3. We write the first the bicyclo compound as the main, then the square bracket we write down in the order of descending order, means big ring, that is 3 member, then 3 member, then in between 2 bridge carbon atoms there is no atoms, that's why it is 0, 330 octane. Next is the example number 5. In that you saw that within the bridge atoms means bridge atom which 1 and 4, carbon number 1 and carbon number 4 is the bridge atoms. In that bridge atoms, one side there are 2 carbon, that is 2 and 3. Another side there are 2 carbon, that is 6 and 5. And next side, that is the 7 carbon, that is means the in between that bridge carbon atoms 3 types of carbons are, one side 2, one side 2, one side 1. So we have to mention it by decreasing atoms. So 2, 2, 1, and total number of carbon atoms we are given the numbers 1, 2, 6, 3, 4, 5, 6 and 7, that is heptane. Next one is the bicyclo compounds 2,2,2 octa 2,5 diene 1, 2, 3, 4, 5, 6, 7, 8 bicyclo 2.2.2 octa 2,5 die in 2, 5 positions. At the 2 and 5 positions, there is a alkene systems. At the 2, 5 position, there is a alkene system. That's why it is mentioned as 2, 5 die-in. So total name will become the bicyclo in square bracket 2.2.2 octa 25 die-in. Next is the example number 7. In that, bicyclo is the main. Then you saw that the one carbon number example number 7. Look at the two example number 7. 1 and 5 are the bridge carbon atoms. One side there is a carbon atoms in the rings in between the bridge, that is 1, 5 bridge carbon atoms. One side is the 6, 7, 8. Another side is the 2, 3, 4. Another side is the 9, 10. Means the 3, 3, 2 is the number of carbon atoms in the ring systems. So bicyclo 3.3.2 deck 2 ins is the systems. Next, 3 bromo bicyclo 4.2.0 octane. Okay, here is at the position number 3. There is a bromine, so this is a 3 bromo bicyclo 4.2.0 octane. Next is the bicyclo 3.3.2 deca 3 ins. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 3, 2 deck 3 in systems. So numbering given to the rings where alkene systems are present. So in this way we are given the name to the compounds. Next example is the rings having the one side bridge head. One side of the bridge head is the 1, 2, 3, 4 carbons. Another is 1 carbons, and the in between bridge 0 carbons. So in the descending order, 4, 1, 0, 1 methyl bicyclo 410 heptane. Next one is the 3 methyl 1, 2, 3, 4, 5, 6, 7, 3, 2, 2. Total number of carbon atoms are the 9 nonanes, and at the 3 position there is a methyl group, so the 3 methyl bicyclo 3, 2, 2 nonane as the names, IUPAC names. Next one is the bridge carbon is the 1 and 5. One side 1, 2, 3 carbon, another side 1, 2, 3 carbon, in between 2 carbons, so 3, 2, 3, 2. Total number of carbon atoms are the 10, that is decane, but is alkene system in the on the number 2 to deck 2 in as the parent name. Next is the biphenyl compounds. Next one is the biphenyl compounds. So in case of the biphenyl compounds, we have to learn the rules and regulations of it. So numbers start from the carbon atom joining the 2 benzene rings. In one of the ring, number 1, 2, 3 etc. are used, whereas for the other ring, number are marked as 1 dash, 2 dash, 3 dash etc. For the one rings, number 1, 2, 3, 4 are given, and for the other rings, numbers are marked as 1 dash, 2 dash, 3 dash etc. So numbering is done in such a way that that get a minimum substituent get minimum possible number in such a way that substituent should get the minimum possible number. So biphenyl is also called as diphenyl or the phenyl benzene or 1,2 biphenyl or linolyl. Biphenyl compounds having the names diphenyl, phenylbenzene, biphenyl or lemonil. So here are the biphenyl compounds. Substituents are there on the two different rings. On the one rings there is a 1,3H, another ring there is a SO3H. These two rings having the biphenyl compounds. So one ring is named as 1, 2, 3, 4, 5. Another rings numbering as the 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. So we can mention firstly the biphenyl compounds, then 2, 2 dash. 2, 2 dash disulfonic acid. Disulfonic acid as the compounds. Next, two substituent on each rings. So numbering one ring is 1, 2, 3, 4, 5, and another ring is 1 dash, 2 dash, 3 dash, 4 dash, 5. So 2, 2 dimethyl groups, 5, 5 dimethoxy, and a diphenyl compound. Next one is here is also two substituent. One is the methyl group substituents and another is the chlorine group substituents. So these two substituents are there. So we can use it as the 4, 4 dash dichloro, 4, 4 dash dichloro, 1, 3 dimethyl diphenyl. Next is the three substituents are the 1 NO2, NS3, COH, NS3, NO2, OCS3, 4, 4 dash diamines, dimethane, 3 dash 6 dinitro, diphenyl, 2 carboxylic acids. This is the next one, diamines. Next, 6, 6 dash dinitro, biphenyl, 2, 2 dash dicarboxylic acid. Carboxylic acid is the functional group set in calling the parent, dicarboxylic acid. Next is the NO2 nitro, 4, 4 dinitro biphenyl, because nitro group is always written as the prefix. Next one is the 2, 6 dinitro biphenyl, 2 dash carboxylic acid. Next one is the SO3H. SO3H groups are there. This is example for practice. Solve this 9, 10, 11 at your homes. Give the names, nomenclatures. Numbering should be given to one ring as the 1, 2, 3, 4. Another ring is the 1 dash, 2 dash, 3 dash. 1, 2 disulfonic biphenyl disulfonic acid. In this way you can, if you not understanding there is one example number first of the same type, diamphanyl 1,2-disulfonic acid. So do the practice at your homes. Now and understand these two groups. Example number 12, example number 13, both are the same, only alkane systems are there. So this is the bicyclo compounds, don't get confused, bridgehead carbon there. Next one is the quinolines. So quinolines, we have studied about the physical, chemical properties, preparation, all about that. In the quinolines, it is not a quinolines, it's the allenes types of the compounds. We'll discuss these topics in the next lectures. Okay friends, thank you very much.